a problem. So initially it is but a theory part you may understand, or there will be some confusion. So it is always better to start with a problem, a simple problem, and that will give you a clear picture and idea how to start with. Now, as mentioned, we had a 5-step procedure for solving moment area method. So 5-step procedure what we had learned in moment area method were elastic curve, bending moment diagram, M by A diagram, slope and deflection. So same type of steps and procedure we are going to learn here. So whatever the form of elastic curve what you had learned in moment area method, the same form of elastic curve we need to draw. Then draw bending moment diagram, M by A diagram. It's a conversion of M to M by A diagram. Now the new thing is to learn how to draw the conjugate beam. So yeah, this particular start will start with conjugate beam pertaining to cantilever beam. So in cantilever beam, one end will be fixed, the other end will be free. So when I mentioned one end to be fixed, the other end to be free, we need to check out which particular end is fixed and other end is free. Whichever end is fixed, in case of conjugate beam, whichever end is fixed in case of conjugate beam, that end will become free, and whichever will be a free end, that end needs to be converted as a fixed end. And on this particular conjugate beam, loading will not be either a point load or UDL or any given form of loading. Loading will be the superimposition of M by A diagram. That is step 3 what you are going to draw. The same step 3 will be considered as the loading on the conjugate beam. And shear force calculation at any section indicates slope, and moment calculation at any point indicates deflection. Now this is a cantilever beam subjected to a point load. So kindly read this statement. For the given cantilever beam of span L subjected to a concentrated load P, at free end, determine slope, that is theta, and deflection, that is delta at the free end of the beam. So this is a cantilever beam of span L. So we shall try to name this as point A and this point to be B now. So whatever the value we are going to calculate at B, if I calculate slope at B, it will be called as theta B. If I calculate deflection at B, it will be called as delta B. Now what is the first step here now? So this is a cantilever beam carrying a point load P, and the distance between the 2 points is L. That is nothing but the span of the beam is L. Now first step is to draw an elastic curve here. Draw an elastic curve. Consider this as a beam and you try to apply a load on the top. What will happen is the beam will deform in this particular fashion. So deformation in this particular fashion, wherein one end is fixed, the other end is free, is nothing but an hogging pattern. If you check out, this is an hogging pattern. If the same load had to be applied towards a bottom fiber, what will happen is the beam will deform in this particular fashion, which is sagging pattern. So generally, hogging pattern bending moment diagram are to be considered as negative, and sagging pattern bending moment diagram are considered to be positive. Now here, if I apply a load at P here, this will deform in the form of hogging pattern, and hogging pattern bending moment diagram needs to be drawn towards a negative side. Negative side means whatever is above the top fiber of the beam is positive. Whatever is, we are going to note down the points below the bottom fiber of the beam shall be considered to be a negative ordinate. So same conditions will be prevailing as per the graphical procedure. Here, since the beam hogs, we are going to draw it towards the bottom fiber of the beam. Now how to calculate this here? If we want, we can calculate as M is equal to P into X, and X will vary from M is equal to P into X, and X will vary from 0 to L. So if I substitute X as 0, so moment at B will be 0 and moment at A will be PL. So here this is an elastic curve. Now since A is fixed here, slope will be 0 and deflection will be 0. Now B is free end, slope and deflection needs to be calculated. What are these now? These are the parameters pertaining to real beam. Now how to calculate this? To calculate this, we are going to calculate shear force. To calculate this, we are going to calculate moment. Where? On the conjugate beam. So to find out slope, we need to calculate shear force. To find out deflection, we need to calculate moment, which should be on the conjugate beam. Now as mentioned, First we are going to draw elastic curve. So elastic curve will be in the form of hogging, and moment calculation we have calculated here. So section will start from B. It will proceed towards the left hand side, and consider any section here which is at a distance of x now. So moment created will be in clockwise direction. So it is m is equal to p into x. So x will vary from 0 from point B, and till A it will be L. So x will vary from 0 to L. When I mention x to be 0, so if I bring it closer here, so when I mention x to be 0, I will be at point A. If I go on increasing the distance of x, ultimately I will reach to A. So when I reach to A, total distance traversed by x will be L. So when I mention x to be L, so I will be calculating moment at A, which will be P into L. Now here L is to the power of 1. So if it is L is to the power of 1, which indicates x is to the power of 1. Any equation or any line when x is to the power of 1, which is equal to y is equal to mx plus c, which will be an equation of a straight line. So we are going to draw it in the form of a straight line from A to B. Moment at B is 0, moment at A is P into L. So moment at B is 0, moment at A is P into L. So we are going to draw a bending moment diagram on towards the negative side. Why negative? Because it is going to hog. Then the same diagram we are going to convert it as M by EI diagram. As EI value is constant here, so it is PL here, so it will be PL by EI. Next is a conjugate beam. See, as stated earlier, A is fixed, B is free. So what will happen in conjugate beam? A will become free and B has to become fixed. On the other hand, if B had to become fixed and A will be free, it will be the reverse option. B will become free and A will become fixed. So since here A is fixed here, A will become free in case of conjugate beam. So B is free here, so B will become fixed in case of conjugate beam. So what we have drawn here is conjugate beam. And on this conjugate beam, you are going to superimpose M by A diagram. So M by A diagram is here, PL by A. Superimpose means it's already been drawn towards the bottom fiber. So same condition, you draw it towards the bottom fiber. And the magnitude, everything will remain same. Once you draw, you show the arrow touching towards the beam. If the load is on the top, the arrows needs to be shown in the bottom direction. So these arrows are upward. What it indicates, the load is upward, that is elastic loading is upward, which will try to move the object in the upward direction. It will try to move the structure or the beam in the upward direction. As a resultant, the reaction has to be in the downward direction. This reaction at B is nothing but the resistance offered by the support B, which will be a new form on the conjugate beam. Why it has to be shown upward? Downward, because loadings are in the upward direction, so resistance should be in the downward direction. Likewise, with reference to point B, this load will try to rotate in clockwise direction. Resistance will be in the anti-clockwise direction called as MB. Now we need to find out these two parameters. That is, as this is a vertical force, I call it as VB. As it is a rotation force, I call it as MB. Now what VB will indicate? VB will indicate the reaction on conjugate beam. The same will indicate slope on real beam, that is theta B. MB is the moment on the conjugate beam. The same will be indicated as deflection on the real beam. Now how to calculate this? So reaction and moment, it is based upon the equations of equilibrium. We have three equations of equilibrium. Summation fx0, summation fy0, and summation with respect to a support is equal to 0. Now when I mention support is equal to 0, in this particular beam, A is free, B is fixed. So I shall take with respect to fixed support. So I shall take moment with respect to B and calculate the value of MB. Calculation or computing the value of MB in this particular condition indicates deflection at B. And now how to do that? It is quite simple here. To find shear force at B, take summation Fy is equal to 0. I shall draw the diagram here again now for better understanding. So B diagram or M by A diagram with conjugate beam was drawn like this, wherein the value of PL by EI has been considered here, B is point is considered here. As loading is upward, reaction is downward here now. You kindly check out here. We need to follow a protocol here. The rules say same what we had learned in our school days. All upward directions are considered positive, all downward directions negative, all right hand side positive, all left hand side to be negative. Likewise, all direction of rotation in clockwise to be positive, all direction of rotation in anti-clockwise to be negative. Same rule and same protocol we are going to adopt here now. Now what the condition says is, now reaction at B is downward. So what sign we are going to adopt here? Negative. So we are going to consider this as minus VB. And all forces are upward. Now what is the shape of this particular geometry now? It's a triangle. Now triangle, that is uniformly varying load. So triangle area is what? Half base, that is base is L, and height is how much? PL by EI. Half base and PL by EI. If I do this, what is this? It's a net force. And net force itself is shear force. Half is an area of the triangle what we are going to consider here. PL by EI is the height of the triangle, and L is nothing but the span of the beam. If you reframe the equation by considering this or shifting towards the right hand side, minus sign will be converted to positive, and reframing the equation is PL square by 2EI. Now what is this VB now? VB is basically a shear force at B on the conjugate beam. This is conjugate beam subjected to M by EI loading. So this same condition, so same shear force is referred to as slope on the real beam. Same shear force is referred as slope on the real beam. So this itself will be called as theta B. Whatever the shear force you have calculated, how we have calculated, again check out. Considering summation Fy is equal to 0 minus VB. Why minus? Because all downward force to be negative, all upward force to be positive. Here reaction is downward, so minus VB, plus half PL by EI, that is height of the triangle, into base of the triangle, which is L, which is equal to 0. So VB is equal to PL square by 2EI. This is, VB is shear force on the conjugate beam. The same thing we are going to call it as the slope on the real beam. This is what is required to us now. Like same way, there are three equations of equilibrium. One is already been used, that summation Fi has been used now. Now we are going to make use of summation of support is equal to 0 or moment is equal to 0. Now in this particular diagram, A doesn't have a support, B has a support now. So we shall consider moment with respect to B is equal to 0. When I consider moment with respect to B is equal to 0, this UDL will try to rotate in clockwise direction. Resistance has to be in the anti-clockwise direction. And since this is a resistance rotation force, I call it as MB now. Now this MB, since it is an anti-clockwise direction, so it is minus MB. Then what are direction? So positive. Half height of the triangle PL by EI. Base of the triangle L. Now this 2/3 is centroid of the load. Now centroid of the load, where I am going to calculate? With respect to point B. So with respect to point B, how far is centroid here? 2/3 of base. 2/3 of base means 2/3 of L. So that's why we are including this as 2/3 of L is equal to 0. So again, considering MB taken on the right hand side, the minus will be converted to positive. MB is equal to PL cube by 3EI, because 2 will get cancels up. So PL cube by 3EI. Now what is this MB? MB is nothing but the moment at moment at B on the conjugate beam. So same thing is referred to as, same moment is referred as a deflection on the real beam. Deflection on real beam. So this, whatever moment we are going to calculate, that itself will be called as the deflection at the real beam. So what we required was, slope on the real beam will be PL square by 2EI. This is what we have calculated. And deflection at B will be called as PL cube by 3EI. So this is what was required to us to calculate slope and deflection by conjugate beam method. Pretty simple. Things to remember here is, free end will become fixed for conjugate beam, and fixed end will become free. Then apply equations of equilibrium. What are those equations of equilibrium? Summation Fy 0 and summation with moment of summation of M is equal to 0. If we are if we have followed this, then the rest everything will remain same, and it is a simple mechanics calculation of reaction components. Thank you.